Hello everyone, my name is Arifat Shine, and today I will do a demonstration about the installation and simulation of the ORIX project. So without further ado, let's get started. First, we generate our corresponding directory, which I already did, and also then we can download the corresponding repositories using git clone commands. I already downloaded them as well, as we can see here. And we have to install the corresponding dependencies such as CMake, Civic, and Go, and let's check them as well. As we can see, we have a correct version of the CMake. We also have the correct version of Civic, and also we have the correct version of the Go. After that, we can move on to the basic directory. So the main thing is that we have to change our branches. We are not going to use the main branch. We are going to use the updated version of which is named as updated except. And then we are going to uh, create our build directory. We are gonna see some warnings, but they are nothing to worry about. And we are gonna in few seconds that we are gonna have an error-free installation. After Fake is installed, we can move on to the simulator. Again, we are gonna change our branch as well. And then we are gonna build the project. In this section, we defined some of the parameters of the enhanced core sims, and also we defined some simulation parameters for xApp as well. For more details, you can check out them yourself, but we are gonna move on with the simulation steps. So for that one, I'm gonna open my Terminator. First, we are gonna open our enhanced core sims. And then we are gonna start our emulator. And then we are gonna start near RTWIC. As we can see, E2 agent and near RTWIC can successfully communicate. So then we can move on with the risk optimization xApp. Here we're gonna utilize xApp risk modify.file. As we can see, using this script, we can give the method as an input and also face tables as an input. For this optimization, we have 4 different methods, the default version one, and we implemented iterative method, we implemented concise method or the code method. And also for face tables, we have 3 face shifts for 1 bit, for 2 bit, and for 3 bits. For more details about both of these input features, you can check out the README file as well. So let's get started with the iterative method. For basic tables, let's get started. Therefore, as we can see here, the subscription requests and also E42 interfaces. And also we can see that this is optimized according to our accept. So let's move on to the concise methods. Again, we can see the subscription request again, and also E40 interface again. And we can see this is optimized again. So let's move on to the codebook method. There's a slight nuance when using codebook methods. Let's talk about it now. In order to use the codebook method, we have to generate codebook first. For that reason, we have to run another xApps named as xApp-based codebook generation. So that's what we are gonna do. But in order to generate some codebooks using this, except we have to define some positions in the risk simulator using the positions.csv file. As you can see, we have like 5 positions. So let's up the number of positions. Let's say we had 1 position actually, so let's say 5 now. And let's change them randomly. And then we can start the risk simulator again, then the emulator agent, then the near rig. So instead of now implementing xApps modify, we are gonna use xApps codebook generation file. So as we can see here, we can give an input as which amount of number of codebooks it generates. So default value is 10, but we want to generate 5 codebooks, and this is important such that n input should not be more than the number of positions in the position.csv file, because then you are going to generate the same codebooks for the same locations. That doesn't make sense. So let's move on, and let's say we want to generate 5 codebooks. When this xApp is run, it actually looks for distinct positions and additionally enhanced cosines loops over the positions. So there can be some slight alignments during the timing synchronization. So instead of 5, we might sometimes get 4 codebooks in total. We are still trying to improve this methodology, but sometimes it works. Sometimes it can produce one less amount of codebook, but I don't think it should be a problem as of now. As we can see, after all positions are looped over, we can see the subscription direct requests. So let's check our codebooks. As we can see, we have our codebook generated under the name of codebook.json file. So we are going to use this one. But before doing that, we have to change the positions again, because these positions were used to generate the codebooks. So we have to input another a brand new position. Let's say so. After a brand new position is defined, we can start the enhanced code series, our emulator agent, near rig. And now we are going to use the xApps modifier again. Instead of iterative or constant method, we are going to use the codebook method. For codebook method, we do not have to define any basic tables. As you can see, because due to the timing mismatches, we actually generated 4 codebooks. We are still trying to improve this methodology, but we can see that this can be optimized using these codebooks as well. That was actually all. We covered entire installation and simulation of the Ghost ORIX project using enhanced code simulators, also an updated xApp. So thank you for listening. Have a good day.